What I want to do in this video is explore the idea of a unit vector. And a unit vector is just a vector that goes in a particular direction that has a magnitude of 1. So let's take an example. Let's say that I have the vector, let's say the vector A, and it in the horizontal direction, for every 3 that it moves, in the vertical direction it moves up 4. It moves up 4. So what else do we know about this? Well, we could figure out A's magnitude, and we could denote it like this. The magnitude of vector A, well, this would just be the length of it. So let's try to visualize A. So for every 3 that we go in the horizontal direction, we're going to go 4 in the vertical direction. We're going to go 4 in the vertical direction. And so vector A would look something like this. Would look like that. That is vector A. So what's its magnitude? Well, the magnitude is just the length of this vector right over here, and we could use the Pythagorean theorem to figure this out. This length is going to be the square root of the sum of the squares of the other two sides. So this is just the hypotenuse of this right triangle. So this is going to be 3 squared plus 4 squared plus 4 squared, or this is going to be the square root of 9 plus 16, square root of 25, or it's going to be equal to 5. And you might have just recognized that this would be a 3, 4, 5 right triangle. So the length of this side right over here is 5. So I could say the magnitude of A is equal to 5. So this is clearly not a unit vector. It has a length, it has a magnitude of something other than 1. But let's say we wanted to construct a unit vector that has the same direction as A, but has a length of only 1. So another way of thinking about it, let's say we wanted to figure out a vector that goes in the exact same direction, but it has 1/5 the magnitude. It only has a magnitude of 1. So what could we do? Well, if we scale everything down by 1/5, if we were to multiply each of these, I guess you could say, components of our vector A by 1/5, or another way of thinking about it, if we divide each of these by the magnitude of A, then we could construct this unit vector. And I'm going to call that unit vector, I'll call it A, but instead of putting an arrow on top, I'm going to put, actually, just to not confuse ourselves, let's call it U for unit vector. And to also make it clear it's a unit vector and not just a normal vector, I'm going to put this little hat. So instead of this little arrow, when you put this hat, this denotes that you're dealing with a unit vector, a vector with magnitude of 1. So the unit vector, we could write it down as it's going to be equal to each of these components for A, we just divide by the magnitude of A. We just divide by the magnitude of A. So this 3 in the horizontal direction, 4 in the vertical direction. Once again, just divide by the magnitude of our vector. And so this is going to be equal to, the magnitude we already figured out is 5. So it's going to be 3/5 in the horizontal direction and 4/5 in the vertical direction. And you can verify. This is going to have, one way to think about it, the ratio between these two numbers is the exact same thing as the ratio up here. So we're going in the same direction, but the magnitude here is now going to be equal to 1. And you can verify that. Let's do that. So what's the magnitude now of our unit vector? Let me write that hat a little bit. That hat got a little crooked. What's the magnitude of unit vector U? Well, it's going to be the square root of the sum of the squares of these two components. So it's going to be the square of 3/5 is 9 over 25, plus the square of 4/5 is 16 over 25. And what's that going to be? Well, 9 plus 16 is 25, so it's going to be the square root of 25. So that plus that is 25. 25 over 25, which is just going to be equal to the square root, or I guess we're taking the principal root, the positive square root of 1, which is just equal to 1, which is exactly what we wanted. It goes in the same direction, but magnitude is 1, and that's why it's a unit vector.